Hi, and welcome to What's New in SQL Tools for Developers. This is a session for SQL Bits 2020. Before we get started, we're just going to introduce ourselves real quick.
Uh, Thanks, Drew. Hi, I'm Udeesha Gautam. I am a software engineering manager in SQL Tools and Experiences team. I have been working on developer features like SSDT, DacFx, and now ADS. And currently, we are trying to bring in more and more developer experiences onto our cross-plat tools.
Thanks. I'm Drew Skwiers-Koballa. I'm a program manager on the SQL Tools team, and I focus quite a bit on database developer experiences, including SSDT and Azure Data Studio. And one of the things that I have really enjoyed about joining this team is our focus on some of these open source tools like Azure Data Studio. In this session, we're going to start by taking a look at from a high level of what's new in SQL overall before we dig into what's changed in the tools, notably Azure Data Studio, Visual Studio Code, SqlPackage, the functionality of SQL Projects overall and some exciting developments in that space, and then last but not least, SQL Client and .NET Core. Within the last year, we've seen the release of SQL Server 2019. From a high level, SQL Server 2019 brought us improvements in parallel processing and in memory operations. But for developers, it's important for us to note the expansion of graph capabilities in the SQL Server engine. One of the flagship features for SQL Server 2019 is the introduction of big data clusters. They're an extremely exciting space that enables us to extend the SQL Server engine to external data sources. This gives us the capability to work with data sets that are much larger than they've been in the past. Now, while the SQL Server product has had many changes in that iteration, we've also seen a lot of changes to the Azure database platform. Not only do we have Azure SQL, but we also have PostgreSQL, MySQL, and MariaDB all now coexisting in that Azure database engine space. One new change to SQL that we're going to highlight a couple times today is Azure SQL Edge. Now, Azure SQL Edge is an edge optimized engine. The workload itself has been reduced to a small footprint, allowing it to focus on IoT devices. Things such as a Raspberry Pi become your Azure SQL Edge engine host. Across SQL in the last year, we've seen the continued commitment to those kind of cross-platform server environments. SQL Server 2019 is the second release now that runs on Linux as well as Windows. And we know from the tools perspective that our users are running on cross-platform clients, not just Windows, but often Mac OS and Linux. So we're continuing to invest in those cross-platform experiences. That doesn't mean that we're ignoring the tools for developers that really enable automation, like those command line tools. I took a look at the last 6 months and kind of put together this timeline to show you visually what tools have been getting more releases than others. It's not likely a surprise that there's a release for Azure Data Studio at least once a month. And then we've seen a couple of releases for SqlPackage, the command line tool, as well as for SQL Server Management Studio. If we start to dig into Azure Data Studio, if you're not familiar with it, briefly, it's our open source and cross-platform tool that's focused on data scenarios. So if you're a data-centric or a data-adjacent user, you're going to get a lot of value out of this tool. Both for the client side and the server side, it's going to be cross-platform. So whether you're running Windows, Mac OS, or Linux, and whether you're connecting to a SQL Server in your data center, or Azure SQL, or PostgreSQL, or even KQL now, you'll be able to utilize Azure Data Studio for querying, management, and development. The releases of Azure Data Studio are continuous. So in the last 12 months, we've seen 11 major releases, and we plan to continue that cadence. Now, the Onboard deployment wizard for Azure Data Studio is one of the things that you're going to see featured today, and that allows you as a developer to quickly spin up either Windows or Linux installations of SQL or container instances across different engines. Before we dig into that deployment wizard, I did want to talk about a few other features quickly. From the querying and navigation side, the drag and drop capability for columns and tables has been added, as well as there's a query history engine extension that can be very helpful. The database engine um, coverage for Azure Data Studio continues to expand. It's almost hard to keep up with these days. The PostgreSQL support covers Azure AD, so it's a really full experience if you're a PostgreSQL developer as well. The deployment wizard now covers big data clusters and Azure SQL Edge, so if you're exploring those spaces, that's a great place to start. Notebooks have added support for remote Jupyter books being pulled directly from GitHub. And then if you have notebooks open, could be hundreds of them, there's a search capabilities that allows you to search across all of those notebooks. Now we're going to talk about some extensions within Azure Data Studio today, but I did want to make sure that we touched on the Schema Compare extension as well as the DacFx extension as developers. Those functions with the data tier applications can be very helpful, and we'll dig into those in a bit. But the SQL Assessment API, if you're someone that crosses over into some administration space, it can be helpful to use this extension to quickly evaluate an instance of SQL. Now, let's go ahead and dig into Azure Data Studio.
Thanks, Drew. So as Drew mentioned, SQL now has multiple different offerings, from SQL Container to big data clusters to Azure SQL Edge. And as the cross-plat tool for SQL, Azure Data Studio has come up with different ways for you to get started with these different offerings. So let's get started with the deployment feature inside of Azure Data Studio. As you can see here, there are different deployment options, and all of these deployments are notebook-backed deployments. So while the deployment is going through, you can actually see it progressing through different notebook cells. Today, we will talk more about the different kind of deployments for Azure SQL Edge. As some of you might know, Azure SQL Edge is a SQL instance which is optimized for Azure IoT and Edge devices. So there are multiple flavors of deployments that Azure Data Studio provides for Edge, which are specific to the requirements of Edge. Here, these deployments range from offline deployments to online deployments to bulk deployments. When I say offline deployments, I mean these deployments, the top two deployments, will not be using your Azure subscription. They will rather use a local Docker container and create a container image of Azure SQL Edge onto your device. The next ones are online deployments, which will actually use your Azure subscription, and they will create a SQL instance either on an Azure VM or on an existing device. They will not only install SQL Edge on these devices, but they will also connect your devices to a Azure IoT hub. They can create a fresh IoT hub or reuse an existing IoT hub. But the connection made through IoT hub to the devices makes it easy for users to then manage these devices in future, like installing new updates onto them, adding new modules onto these devices, and so on. So today I will walk you through a local instance deployment of SQL Edge, and then I will give you a glimpse of an IoT hub-based Azure SQL Edge deployment as well. For the second one, I'll probably not go through every steps in the interest of time. So starting with the local container instance, once I select this, it asks me a set of questions. It asks what the instance password should be, what is the port I should use for it, and then it asks for some optional Docker settings as well. So once I provide the password and I say open the notebook, it actually creates a notebook, a parameterized notebook for me, which will run each of these commands to create a Docker-based container and install Azure SQL Edge for me on that. It will then give me an option to connect to it. It will also give me an optional cell if I want to clean up later on once I'm done with my testing. This kind of deployment is very useful in cases where we are doing some development of databases and we need these lightweight edge deployments to be able to validate our databases against them. So here now the deployment is complete. It gives me a link to connect to the instance running on the local container. And once I connect to it, I can also query the version to it on it, and I will see that it actually installs the Edge developer instance for me. Now, as I promised, I will also show you how the IoT-based deployment will look like. So say if I select the Azure IoT Hub and VM instead of local container, it will ask a slightly different set of questions. It will ask for my Azure account, resource group. It will ask me information about the Azure VM that it wants to create as a SQL Edge instance. And then finally, it will ask me the same questions that it asked for local container about the username, password, and the port. If I go through this deployment, it will actually create an IoT hub, an Azure VM, and connect the two for me so that I can continue managing the device through IoT hub. And to show how it looks on the portal, this is how it will look once it is fully deployed. So this is my resource group that it created. Inside that, it created an IoT hub for me. And inside of that, it created a device for me. And these are the different modules that it installed for me onto that device, including the Azure SQL Edge. To connect to this SQL instance, it is very similar as the local host instance. Using the IP and the port, I can connect to this as well. Now that we have created both of the IoT-based as well as the local host SQL, I want to remind you that this is installing the instance of SQL. This is yet not developing the database onto the instance. And for that, we will see a demo in some time. For now, back to Drew.
I wanted to be sure to highlight some key interface features within Azure Data Studio, the things that kind of really make it a great experience for developers. The first is embedded source control. So this could be tied into Git or a different source control provider. There's an Azure Resource Explorer. So while the connections pane in Azure Data Studio makes it easier to get connected to your whole server estate, the Azure Resource Explorer speeds up that discovery for Azure resources tremendously. There's a built-in terminal right within the interface, so that could be a PowerShell or a bash operations that you're able to execute right within the interface. And then last but certainly not least, in the query editor, there are snippets. There are some that are built in that come right out of the box. And then this is a really customizable experience where you can create and add your own snippets so that while you're coding, you can have all of those shortcuts that you would like. We're going to dive into those right in Azure Data Studio in a minute, but I did want to take a moment to make a quick plug for the Azure Data Studio codebase. I had mentioned earlier that one of the things I'm really passionate about with this team is the work we do with open source software, and the work done on GitHub by the Azure Data Studio team is done transparently, so the link is right there on the slide, and you are invited to certainly stop by that repository, vote on or submit feature requests or bugs that you find and participate in the conversations. The PMs and engineers behind Azure Data Studio are there on that repository working and are ready to engage with you. We do welcome external contributors to Azure Data Studio. So if you're unsure of where to get started, in the wiki there are instructions for building Azure Data Studio on your local machine. If that is too much, but you are intrigued by the idea that we're working out in the open and features hit that repository before they're released in a stable build, there is a nightly build of Azure Data Studio. We have an insider's version that you can grab off the repository, grab the installer for your operating system, and try out the latest that we have to offer. We're going to take a look at a few key interface features within Azure Data Studio. The first is the integrated source control capability, where if you have a folder that's been opened that's tracked in source control, any changes, for example, this script that we've added, can be then easily committed and tracked within the source control pane there. Beyond the ease of source control use, the connections pane is extended to include an Azure Resource Explorer, which allows us to dig right into any SQL-related resources that we have in Azure. So whether it's a SQL database, a SQL Server, or even a PostgreSQL instance, we can quickly find and even open the connection to that server. So in this case, we're able to even connect to a PostgreSQL server since Azure Data Studio connects to multiple database types. We can even grab and query the data, which looks great. However, the use of the Azure Resource Explorer also speeds up our access to the Azure Cloud Shell. So this is where you can do PowerShell or Bash commands. I'm going to go ahead and grab the PowerShell Azure Cloud Shell, and it brings it right into the integrated terminal in Azure Data Studio. So again, I still don't have to leave Azure Data Studio to do this work. Let me do get AZ resource group, where resource group name like group. See if I have any resource groups with my name in it. Yep, I do. It's in the central US location. And you're able to extend that Cloud Shell through PowerShell or Bash if you had selected that shell. But the integrated terminal really makes things quite a bit easier because then you also have access to your local terminal if needed. Now, the query editor experience in Azure Data Studio can be extended in a number of ways, but probably the quickest and biggest efficiency gain is the use of snippets to drive the query editing experience. So I'm going to go ahead and start a new query in AdventureWorks. A couple different snippets come right out of the box. So for example, create table gives you a snippet with different tab stops, where if you name the table customer info and then hit tab, it moves you to the next tab stop to define the schema. So I'm going to put this in the sales schema. And that gives you a specific code editing experience. We're able to move quickly through it. As a developer, I've got different code patterns that I might use, and so you're able to define those custom snippets in Azure Data Studio by opening up the command palette, and you can search for configure user snippets. And this is going to ask you what language do you want to be configuring snippets for. In this case, it's SQL. And these snippets are available then when you're using a SQL language file. The syntax to define custom snippets is not too difficult. It is in a JSON file, but you're defining what prefix would be used in the code editor to bring that snippet up, and then the body of the snippet line by line. This special syntax here with the $ curly brackets defines those tab stops. So as you bring the snippet into the editor and then move through it, you can define multiple spots where that code is entered. This snippet here has one tab stop for the main code, and then the rest of it is a try-catch block that I want to make sure that I use as much as possible in my development. So if I open up a new query editor and do SQL try-catch, This is going to offer me the snippet for SQL try catch that I've defined custom, and then all I have to do is add my main code in that try catch block. So I've added the code, and then the heart of the script here, but the remainder of it was auto-populated by the snippet that I defined, and I can use that over and over and over again. So it really does bring quite a bit of efficiency to editing. Azure Data Studio is a fork of Visual Studio Code. So we're able to extend quite a bit of the functionality involved in connecting and querying database servers such as MS SQL and Azure SQL into the MS SQL extension for Visual Studio Code. So if you need some light database capabilities within Visual Studio Code, I invite you to install that extension and utilize it for those functionalities. However, we understand that as database developers, sometimes you go beyond database development into other realms. So I wanted to highlight two capabilities within Visual Studio Code that are going to be very complementary to your workflow potentially. The first is the Docker extension, which, especially if you're getting your feet wet with containers, is a graphical option for managing those containers. We'll dig into that in just a second. And then the other one is Azure extensions, which can give you kind of UI capabilities for managing functions, app service, pipelines, and storage within Visual Studio Code. So let's dig into Visual Studio Code and the Docker extension. In Visual Studio Code, we have the Docker extension designated by its icon over here on the left. And I have deployed a container that is the latest SQL Server 2019 image. With the Visual Studio Code extension for Docker, I can quickly view the logs for the container, which can be helpful if something went wrong during deployment or after the container has been running, or we need more information to diagnose. We can also attach the shell to the container, so we're getting access to bash within the container. So this is not my workstation, this is within the container. We're able to navigate the file system and execute other commands as needed. And then last but not least, if we've deployed a container and we need more information about its definition, perhaps we forgot the port that we forwarded it to on the host, the inspect command gives us the full container definition. And within it, we're able to find information like the host port that we forwarded 1433 to, 61433. I did mention the MS SQL extension for Visual Studio Code earlier. It has the Object Explorer that is navigable, as well as the ability to write queries from scratch and grab ones from the Object Explorer. On top of that, the query history capability keeps track of work that we've done within Visual Studio Code. Earlier on, I had mentioned SqlPackage, the command line tool, and how it can help with deployment automations. SqlPackage is centered around two file types, the DacPack and the backpack. DacPack being the data tier application, or DacPackage, and it contains a definition of the whole database schema, all of the SQL Server objects that come from that database. A backpack takes that a step further into a different file type that contains not only the schema, but also the data from that database. The SqlPackage tool then centers around being able to extract and publish a DacPack, publish being an operation where either an existing database is updated to the schema definition from that DacPack file, or creating a new database. Backpack, export, and import can bring a full backup copy of a database out or restore a database to a new state from that backpack. Last but not least is the schema comparison capabilities of SqlPackage. You can either get a report that shows the drift between a database at a certain point in time and then with the changes. You can also get scripts that can help you update a database to a new schema state. The command syntax for SqlPackage is great to know because it is a command line tool, but it's not too complicated. The first parameter that you're going to see is the action parameter, and that's where you would define whether you're doing an extract or a publish or an export or an import type operation. And then you can have one to many additional parameters, for example, the source server or database name, or a target file for the output. It is good to know that as you look at documentation and references for SqlPackage, you may see the parameters in their short form names. They're just quicker to type a lot of times, and they're not too hard to guess which parameters they are, but you might see those short form names as you research more information about SqlPackage. We're going to take a quick look at a SqlPackage operation to extract a DacPack from a database and then publish a new database from that schema. On the server, we've got this database AdventureWorks LT 2019 that we're going to target. This database has data in it, so if we select top 1000 from the tables, we're gonna see some data. I'm going to do this scripting from the terminal integrated right in Azure Data Studio, but you could do this from any terminal. This is a command line tool, so it's really ideal for automation. That first parameter is going to be our action parameter. So we're going to define that we're going to extract the database first to a DacPack. The source server name that we need to define for the action is going to be our local host. And then the source database name is AdventureWorks LT 2019. Our last parameter that we need for this command at the moment is target file. I'm going to go ahead and drop this in my users folder. Extract operation is just going to take a few seconds because we're working on a smaller database here. It's going to extract the schema from the database and then drop it into that data tier application file right on my computer. Now to go in the other direction, to publish this DacPack, we're able to do so by defining a source file name, which is going to be that same target file name that we described earlier. And then we're also going to define a target server name. I'm going to publish back to my local host just for simplicity, and target database name. In this case, I'm going to call it empty AdventureWorks. Looks like source file name is incorrect. I needed to do source file. And with this deployment, the reason why I called the target database, the new one, empty AdventureWorks, is that this deployment is going to be deploying the schema from that DacPack file. That's the whole contents of a DacPack. There's no data contained in a DacPack. So this is really a rich development environment coming from the DacPack, where if I look at my server now, and check out those databases, I have empty AdventureWorks, and in there, if I select top 1000 from a table, I'm not going to see any data. But that SqlPackage command line tool gave us a really quick way to be able to basically clone a database schema, publish it to different databases. That DacPack file still exists on my user folder, so I could publish it as many times as I need to without having to go back to that original database. SqlPackage went general availability for the cross-platform versions in late 2019, so SqlPackage is available on all platforms. It is part of the foundation for the deployment features within Azure Data Studio because it does give us those DacPack type operations. Now, data tier applications are also an integral part of SQL project development. Up until now, we've known and utilize SQL project development through Visual Studio and SQL Server data tools, currently available in Visual Studio 2019 as the data platform workload. And this continues, but we're also adding an additional way to interface with SQL projects, and that's through the SQL Database Projects extension in Azure Data Studio. This is really exciting because this is a great way that we're able to make SQL projects cross-platform, but there's going to be continued compatibility between SQL Server Data Tools and Azure Data Studio's SQL Database Projects extension. So it does leverage the .NET Core SDK. We talked about the foundations built by SQL Project that gives us the ability to do that develop, build, and publish lifecycle on any platform. This extension for Azure Data Studio for SQL Database Projects went into preview in September 2020, so it is now available. A really important concept to understand if you're digging into SQL projects for the first time is the idea of declarative database development. This means that as a developer, you get to focus on the desired end state. You're writing create statements, and then the tooling through the build and publish process manages all of the change and migration steps. Because you're focused on create statements, this really does facilitate version control. Then during the build process, the target database engine that's defined by that project is used to validate and compile that whole data tier application. Finally, then once you're publishing, that's when the tooling manages whether or not the database is at that desired state and what kind of alter statements need to be executed. And then finally, you can use Schema Compare within declarative database development against whether it's a production or a test environment, as well as previously compiled DacFx or data tier applications. And those can be used multiple times to publish to different servers. So it gives you a lot of flexibility, while as a developer, you're really focusing, what do I want this application to look like at the endpoint? We have a great demo here on the SQL Database Projects extension in Azure Data Studio. So let's take a look.
All right, let's get started with database projects. As Drew mentioned, we have a new extension called SQL Database Projects, which helps us with the development lifecycle of a database project, from create to build to making changes to incrementally deploying this project onto the server of our choice. So for today's demo, we will just go through this life cycle and deploy this project to one of the edge servers that we previously created. To get started, we need to have a project inside of ADS. And there are three ways to do this. We can either create a new project from scratch inside of ADS, or we can open a project previously created in ADS or even in SSDT Visual Studio. Or we can create a project from a live database through reverse engineering. Since many of us are database developers and we are very familiar with SSDT, let's start with a project that we previously created in SSDT. So here you will see I have a project in SSDT, a very simple project with some tables and views and so on. And now what I can do is I can simply say open project and I choose my project created in SSDT. Note that this is the first time I'm opening this project inside of ADS. And because I'm opening for the first time, it asks me if I want to update my project to be compatible with .NET Core as well. Note that once I select yes, it will automatically make the changes required in the SQL project so that ADS is able to build this project. However, it will not break the backward compatibility with SSDT. That means, although you made some changes in SQL Proj for ADS to be able to understand and build this project, it does not mean that SSDT will stop working. So SSDT will still be able to edit or build this project as usual. Now that we have the project open inside of our ADS, we can start by making some changes to this project. So we can add item, folder, table, views, and multiple other things to the project. Let's start with adding a simple table. I just pick a name for the table and it creates a table for me with a default script. and say I want to make some additional changes to this table as per whatever I want, as per my schema. And now my project has the changes that I wanted to make. The next thing, I can go ahead and deploy this project. So I can build or publish this project. To publish this project, I will go ahead and click publish. Once I click publish, it opens a small dialog for me, which asks me these three different things. Profile is an optional thing where I can load a previously created profile. Profile is nothing but a file, an XML file, which compiles a list of settings as well as a connection string where I want to deploy my project. Alternatively, I can just select the server from my connection dialog and pick a name for my database. So here I'll just select the server that we created, the Edge server that we created on a container on my machine. And then I can pick any project name. By default, it takes the project name as the database name, but I'll make a change to remember it distinctly. And once I have made my changes, I can simply say publish. Once I say publish, this will build and then publish my project onto the database. Now, while this is building, I want to take a quick second and mention that this is using .NET Core SDK to do the building, as well as the .NET Core version of DacFx NuGet to help with the SQL part of the building, as well as to do the deployment. So once the deployment of this project happens, we will see a My Database project demo database created onto the server. Let's refresh it. And once we open this, we see My Database project demo is created onto the server. And this should have the demo table, the other tables present, and views, and so on. So now this is a very simple end-to-end life cycle of a project. But this is just one part of it. As a developer, you always need to make changes to the deployments you have already done. And as some of you might already know, the database projects come in handy in that sense because of their declarative nature. As Drew mentioned, in the project, you can see that all of these tables and views are present in a declarative manner. None of these are any alter or update statements. They are all create statements. So if you want to change the project after some time, imagine I want to make some changes to the table I created, or I want to add an additional table, or I want to remove something, all I need to do is change my database project to the final state that I want my database to be in. I do not need to worry about the delta between the live database and my database project. I just need to worry about the final state in which I want my project or my database to be in. For example, I want one extra column created here. Not only that, I also want a new table created. Now that I have made these changes, if I deploy or if I publish these changes to the database, DacFx behind the curtains will take care of comparing the schema of my live database and my database project and deploy only the changes. To see this in action, let's do a schema compare from the project to the live database. Here, I want to take a moment to mention that Schema Compare is an existing extension in ADS, and the projects are using the same extension to compare the project against the databases. Here, the source of comparison is my project, and I will choose the target as the database that I just deployed. I pick the Edge instance as server. I pick the database that I just deployed. And once I say compare, it will start comparing the schema of my project against my database. Let's give it a few minutes. All right, now that you see that comparison has happened, it comes up with the two differences that we made after deploying the project initially. So it notices that there is a change in demo table and then there is an addition of demo table too. We can also see the details of these changes in scripts, such as below. Now I can, as we deployed before, I can just deploy from here, or alternatively, I can use Schema Compare to apply these changes to the target. I click Apply. It wants me to confirm if I really want to update the target. And once I confirm that, it will start applying the changes to the database. All right. Now, once we go and refresh this, we will see that there is a demo2 table created, and we can also see that there are the extra column added that we wanted to add as part of the change. So this way, the declarative nature of project helps us to keep a single copy of the project schema, or a single source of truth for the project schema, that is your project. And every time you deploy the project to the same database, it makes those changes incrementally without you having to worry about those changes. So now that we have completed the life cycle of a project, let's get back to Drew.
Thanks, Udeesha. In that demo, we saw how the SQL Database Projects extension can be used to take an existing SQL project from SSDT, then editing that project using tsql, for example, to create a table, and then finally to build and publish the project and deploy it against a server. In that instance, we were looking at an Azure Sql Edge instance. Now, publishing this project can be completed against many different servers, so this can be once or multiple times, but we also saw how the Schema Compare extension is complementary to the SQL Projects extension and gives you that extra rich graphical interface to visualize those changes. So I recommend trying out both extensions. Absolutely grab the latest Azure Data Studio and install those extensions if you're interested in SQL project development. Now, the last key item that I wanted to mention today is the Microsoft.Data.SqlClient package. This package is responsible for SQL connectivity for .NET applications. And recently we have unified the .NET Core and the .NET Framework functionality. The last item that I wanted to mention is the Microsoft.Data.SqlClient package. This allows us to, I am really lost on that. The last item that I wanted to mention is the Microsoft.Data.SqlClient package. Now, this package is responsible for SQL Server connectivity and .NET applications, and we've created this as a side-by-side replacement for system.data.SqlClient, which you may be more familiar with. We're doing this to create interoperability between .NET Core and .NET Framework and create a more seamless development experience. So this consolidates that support. It is a side-by-side replacement, so you can continue to use system.data.SqlClient while you bring in Microsoft.Data.SqlClient. The most recent version, version 2, was released just this summer in June 2020, and it adds a host of Active Directory support, including integrated, interactive, and service principal. The great thing about Microsoft.Data.SqlClient is we are succeeding in our desire to create it as a fully covering package for SQL connectivity, because it covers .NET Framework, .NET Core, and .NET Standard across a bunch of different platforms. So you've got 32 and 64-bit Windows, you've got Windows on ARM, you've got Linux, and you've got Mac OS that are all covered by this single package for SQL Server connectivity. So if you're writing a .NET application that utilizes SQL Server, you'll want to take a look at this package. We really appreciate your time today. However, I do want to make sure that we plug a couple other sessions that could be very helpful, especially if you were intrigued by the Azure SQL Edge information that we shared today in relation to developer tooling. There are 2 sessions. The first is AI on Edge later today, and then Azure SQL Edge Optimized SQL Engine for Edge IoT by Bob Ward on Saturday. There are also 2 other sessions that may be of interest just related to developer tools for data platform development. The first one is Coming Soon, Upcoming SQL Tools Features by Vicky Harp on Saturday, and then DevOps 101 for Data Folks by Alex Gates on Saturday as well. Thanks so much for joining us today. I've got our contact information on the slide here. If you'd like to reach out to Udeesha or I after this event, we'd love to hear from you. That'd be great. Whether it's about any of the content that was presented today or a product that was mentioned, if you have general questions or feedback, please do feel free to reach out. Thank you.